Section 6.6 Solving Quadratic Equations by Factoring Part 2. In this lesson, we continue looking at examples and practicing with solving quadratic equations by factoring. Example 1. Solve x squared equals 10x minus 25. As you can see, this equation is a quadratic equation, but it is not in the standard form. By subtracting 10x and adding 25 on both sides, I will be able to move those two terms to the left-hand side to where x squared is. Once I have this quadratic equation with 0 on the right-hand side, I know that I should attempt factoring the left-hand side. This trinomial is the perfect square trinomial, which factors into x minus 5 quantity squared. Remember that this means the repeated factor of x minus 5 is there. Because x minus 5 shows up twice, it makes no difference if I set it equal to 0 once or twice. For simplicity, we don't have to repeat ourselves and just say that the only possible solution to this equation comes from setting x minus 5 equal to 0. We solve this equation to get x equals 5. Example 2. X minus 5 multiplied with x minus 2 is equal to 28. You may feel that this equation looks pretty easy because you have the right-hand side, actually left-hand side, factored. However, please notice that on the right side you don't have a 0. Therefore, don't try to apply the zero product principle here. It cannot be done. Not yet. First of all, you need to remove 28 from the right-hand side and somehow combine it with the rest of the expression. To do that, you will have to FOIL, combine like terms, subtract 28 on both sides, and only now you should factor this quadratic in order to apply the zero product principle. I will use the trial and error method to factor this trinomial and get x minus 9 multiplied with x plus 2 equal to 0. Now set each factor equal to 0 and solve these two equations. The two solutions are -2 and +9. Example 3. The length of the rectangular sign is 3 feet longer than the width. If the sign's area is 54 square feet, find its length and width. First of all, we need to get a diagram so that we could sort through the information given to us. I know that the sign has a rectangular shape and that length is 3 feet longer than the width. This means that whatever width is, I need to add 3 feet to that quantity to find the length. If I let x represent width, then the length should be x plus 3. I also know that the area is 54 square feet. Nowhere in this problem you are told the formula for area of the rectangle. You should know this formula on your own. It is length times width. If we replace A, L, and W by what we know about area, length, and width from our story, we will have an equation to solve. 54 equals quantity x plus 3 multiplied by x. Distribute x into the binomial first. Notice that x squared being there tells you this is a quadratic equation, but it's not in standard form yet. I suggest to subtract 54 on both sides so that all three terms show up on the right side. 0 equals x squared plus 3x minus 54. Having all terms on the right-hand side allows me to factor that trinomial. 0 is equal to x plus 9 multiplied by x minus 6. Solving this equation by setting each factor equal to 0 will yield x equals negative 9 and x equals positive 6. A warning for you. Whenever you are working with an application problem, please pay attention to the answers you get and a common sense interpretation of those. For example, if x is negative 9, remember that x represents a width of your rectangle. Can you have a negative width? I don't think so. So I'm going to discard this possible solution as something that cannot happen. The only reasonable solution here is if x equals 6, which means width is equal to 6. If width is equal to 6 and length must be 3 feet longer than that, we will have to add 3 to 6 to find length. Therefore, the dimensions of the rectangular sign are 6 feet by 9 feet.